Hello everyone, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Yes, please. Okay guys, now this is a Parmanu series for BARC 2023 and I am going to discuss some important questions from one of the most important subject, that is analog. Are you ready guys? Just after GATE exam, now this is another opportunity for you, BARC 2023. Okay, you have idea about the pattern and what is the difference between the exam pattern of GATE exam and exam pattern of what? BARC exam, right? You have to solve more questions. So that we will solve similar type of questions in this session. Okay, so ECA, everything is fine now. Okay guys, now so please everyone remember that this is the DPP daily practice paper, right? And it is a quick revision of all the subjects. If you find any difficulty, then join our Telegram channel, that is Electronics by Sanjay Rathi. PDF will be available on that channel. Okay guys, and you can also ask your doubts. Okay, so this is all about, right, our channel. Now this is an analog circuit and this is my small introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience. Okay, तो मेरे एक्सपीरियंस का फायदा लीजिए और क्वेश्चन मेरे साथ सॉल्व कीजिए. एंड I have qualified and selected for engineering services exam and these are my ranks and I have mentored more than 1 lakh students for these competitive exams. Now guys, please share the link of this session, subscribe our channel and like this session. Okay, so Ravi Teja, how are you? Before starting session, this is one of the important information for you. We are going to start one important series, that is the GATE 2024 fundamentals. Now simplify your preparation for GATE with BYJU'S Exam Prep, that is from 1st March. If your juniors or if you are focusing on GATE 2024, then start your preparation now. जितना जल्दी आप स्टार्ट करेंगे उतना ही ज्यादा फायदे में रहेंगे. But first of all, we have to get the command over basics, we have to get the command over the fundamentals. And that's why that series will deal with the fundamentals for GATE 2024. So subscribe our channel now. Then guys, I'm going to take one very important workshop, right? Because now some students have doubt. What about engineering services exam? Why ESE? What ESE? How we can start preparation for engineering services exam, right? And what about the syllabus, pattern, eligibility criteria? What are the benefits of engineering services exam? So each and everything I am going to discuss in this session tomorrow at 28, that is 28 Feb at 7:30 PM. Step by step guidance to become an IES officer, that is class 1 officer in central government, that is union government. Okay, so guys, I think you are ready to join that session. So everyone please register yourself on our official website on our app. Okay, so this is a free workshop, each and everything about engineering services exam, that is conducted by UPSC. Then now this is the first question guys, and this is based on what? Linear wave shaping circuit. So we have important topics like what? Linear wave shaping circuit, that is high pass RC circuit, low pass RC circuit. Then what? Diode and its application, BJT, biasing and stabilization, amplifiers, MOSFET, biasing and stabilization, amplifiers. After that, feedback amplifier, oscillators, power amplifier, multi-stage amplifier. Finally, operational amplifier, waveform generator. These are the important topics for BARC 2023. Okay, Karan Gupta, very good evening. Siva, Ravi Chandran. Now, what is the answer for this one? Consider the circuit below. What is the output voltage V out at the end of 2.82 millisecond pulse? This is the 2.82 millisecond pulse. This is the 15 volt. C is connected here, R is connected here. That is not the question from network. This is the question from what? Analog, right? Linear wave shaping circuit, high pass RC circuit or what? Low pass RC circuit. So what is this? High pass or low pass? Everyone give me the comments. Right, yes. High pass or low pass? We will solve some questions, you will get idea. Okay. High pass or it is a low pass RC circuit. That will be the very basic question. And then consider the circuit below. What is the output voltage at the end of the 2.82 millisecond pulse? It is a high pass. Yes, Karan, Siva, your answers are correct. Now, if it is a high pass, then everyone give me the answer in comments box. Now I am going to solve it. Try to understand. This is a 15 volt. Initially, this capacitor will act as short circuit because capacitor does not allow sudden change of voltage. When at the rising age, the output will be 15 volt. Suddenly the output will rise from 0 to what? 15 volt. So what will be the output here? Everyone try to understand. Right, this is the input. Okay, then this is the input. Okay, so suddenly the output will rise from 0 to 15 volt. Output will rise from 0 to 15 volt because initially the capacitor will act as short circuit. Right. After that, now the capacitor will charge. When the capacitor will charge, the voltage across the capacitor will increase and the voltage across the resistor will decrease. Exponentially, it will decrease like this. So at the end of the pulse means at this point, what is the output voltage? Output voltage is nothing but voltage across the resistor. It is a exponentially decreasing function. This time is given. What is the time? 2.82 millisecond pulse. So this time is 2.82 millisecond pulse. And it is a exponentially decreasing function. Okay. Now, so what will be the value here? What will be the value here? Simply V0 is equal to VR is equal to initial voltage e raised to power minus t by tau. 15 volt is the initial voltage. Suddenly it will rise up to what? 15 volt because initially capacitor will act as short circuit. This is the 15 volt supply. Now it will decrease e raised to power minus t. What is the t? 2.82 millisecond. 2.82 into 10 raised to power minus 3, that is the second, converted into second upon tau. So what is the tau? RC. RC. So what is the time constant? 470 kilo into 0.002 microfarad. 0.002 into 10 raised to power minus 6 microfarad. Now, put this value, everyone use your calculator. Yes, virtual calculator is allowed here. Then you can use that value and then you can find the answer. Put this value here. 470 into 10 raised to power 3, 0.002 into 10 raised to power minus 6 here. And then my dear friend, you will get some value. I think that is what? 15 e raised to power minus 3. You can check. 15 e raised to power minus 3, I think so. Okay. So once you will get the answer, because you have to put the time constant RC here. Now, then I think that answer you are giving 0.747. You are getting the 0.747 or 0.94 or 0.282. Yes, everyone. What is the answer? That is the method. That is the method we can solve. Okay. And now, everything about this diagram, because this diagram is very important. What will be the question? So you can check what is the answer. This, please everyone calculate it, put the value here, find the value and then you can get the answer. Second thing, it is a high pass RC circuit. High pass RC circuit, and that's why always remember average value of the output will be 0. Average value of output will be 0 because between input and output there is a capacitor, and capacitor act as what? DC blocking capacitor. It will block all the DC values. And that's why the DC value of the output or average value of the output is always 0 under steady state. When we are calculating, then it will be 0. Okay. And that is called exponentially decreasing function. Okay. I think now you got the answer. Okay then. So that is a simple calculation. Within 1 minute we can solve it. And remember, always get the value of e raised to power minus 1, e raised to power minus 2, e raised to power minus 3 up to this point. 1, 2 and 3. Suppose it is asked what is the e raised to power minus 5, you can write like this. That will give you the value of the e raised to power minus 5 and we can find the value. Okay. Then next one. Now tell me what is the answer for this question. Diode circuit means rectifiers. Half-wave rectifier, full-wave rectifier, bridge rectifier. At the end there will be the rapid round. Okay, are you ready for rapid round? Very quickly we have to solve number of questions. Number of around 15 questions within 20 minutes. So at the end we will solve. Okay. So tell me what is the answer for this question. A full wave 4 diode bridge rectifier. This is the 4 diode bridge rectifier. RL is connected here. That is ground. That is connected here. 120 volt AC is connected here. 10:1. That is the ratio. 10:1. 4 diode bridge rectifier circuit with a 1 kilo ohm load operates from a 120 volt 60 hertz household supply through a 10:1 step down transformer. It uses silicon diodes that one can model to have the 0.7 volt drop for any current. For what fraction of the time does the diode conduct? Does the diode conduct? This is connected here. This is the RL. And we are taking the output here. That is the diagram. Tell me. We have the 4 diodes D1, D2, D3, D4. That is the bridge rectifier. Okay. That is another very important question and directly we can solve it. Directly we can solve it. So it is a full wave 4 diode. RL value is given 1 kilo ohm. 120 volt RMS value is given. This is the 120 volt RMS. So what is the peak value? RMS value into root 2. It will become 120 into root 2. What is the turn ratio? 10:1. So what is the, this is the peak value on the primary side. This is the peak value on the primary side. So what is the peak value on the secondary side? The secondary side is given by Vm by Vp is equal to 1 by 10. That is the N2 by N1. 10:1, that is ratio is given. And therefore Vm will become Vp by 10. It will become 12 root 2. It will become 12 root 2. This is the on the secondary side. Okay. Then what is the drop across the diode? 0.7 volt. Always remember, in case of bridge rectifier, in a positive half 2 diode will conduct and in negative half the 2 diode will conduct. What is asked here, for what fraction of the time does the diode conduct? Means whether it is a positive half and negative half. Total we have 360 degree. So out of 360 degree, what about the conduction angle? What about the conduction angle? If once you will get the conduction angle, you can find the fraction. For what fraction of the time does the diode will conduct? So what is the conduction angle? So my dear friend, remember, this is connected here. If it is a sinusoidal signal, this is like the sinusoidal signal. Now at a time the 2 diode will conduct. The drop across one diode is 0.7. So what is the drop across the 2 diode? 1.4. Now the peak value, we have the idea that the peak value is 12 root 2. On the secondary side, this is 0. This is minus 12 root 2. And this is 1.4 volt. This is called 2V gamma. 1.24 volt. When this is greater than 1.4, then the diode will conduct, otherwise diode will not conduct. And this signal will become, what is the Vi? Vi will become Vm sin omega t. That is 12 root 2 sin omega t on the secondary side. This is called Vi. Now, for this portion, diode will conduct. For this portion, the diode will conduct. Again, for this portion, the diode will conduct. For this portion, the diode will conduct. This portion, diode will not conduct. From this point to this point, the diode will conduct. For this portion, from this point to this point, like this is the theta, this is theta. So for this is the 2 theta, diode will not conduct. Okay. Again, this is the theta, and let this is the theta. Means what is the conduction angle phi will become 360 degree minus 4 theta. 360 minus 4 theta. The theta is the value for which Vi, the magnitude of Vi is less than V gamma, and that's why the diode will not conduct to V gamma, that is 1.4 volt. Now how we can find, this is the omega t. So for omega t is equal to theta, Vi is equal to 1.4. We can write 12 root 2 sine of theta is equal to 1.4. So what is the theta is equal to sine inverse of 1.4 divided by 12 root 2. 1.4 divided by 12 root 2. Everyone please find the value of the theta. 1.4 divided by 12 root 2. That is the value of theta. Now you have to find the 4 theta. Theta from this point, theta from this point, theta from this point, and theta from this point. The total 4 theta. So during one complete cycle, the circuit will not conduct for angle 4 theta. And theta is given by sine inverse of 2V gamma by Vm. Sine inverse of 2V gamma by Vm. Now once you will get the theta, you can subtract it from this. 360 minus 4 theta. Okay. And now how we can find the fraction? Fraction of time for which the diode will conduct. It is in percentage. So that is given by total conduction angle upon 360 degree into what? 100%. So what is the conduction angle? 360 minus 4 theta upon 360 into 100%. That will give you the answer. That will give you the virtual calculators are allowed here. So they will ask this type of questions. So you are getting idea. If they will give you the theoretical question, what is the fraction and so on, so directly you can put this formula theta c. What is the phi c is equal to 360 degree minus 4 theta, where theta is given by sine inverse of 2V gamma by Vm. 2V gamma by Vm. Always remember, if RMS value is given, then find the peak value and find the Vm on the secondary side. So Jayesh 94.74%, that is the right answer. 94.7% of the time the diode will conduct. The diode will conduct. Okay, that is the right answer. Diode will conduct for 94.7%. If you find any difficulty, then you can ask. Join my Telegram channel, that is Electronics by Sanjay Rathi. Okay, so that is on the diode. Now next question. Quickly go for the next question. Okay. Can we prove this? But in a exam, what will be the question? They will ask you what is the, I am just giving you the question. We will prove it. V0 is equal to, let A V1 plus B V2 plus C. Find the value of A, B and what C. So that is the 0.9, this is the 0.1 and that is minus 0.54. That is the answer. Can we prove this? That will be the question. Find the value of A, B and what? C. What are the values of A, B and C? And that will be the answer, general answer, A V1 plus B V2 plus C. Now read this question. The diode shown in the figure, the diode shown in the circuit is of silicon with V gamma 0.6 ohm and RF is equal to 20 ohm. And this is what ohm? 180 ohm. The diode shown in the circuit is of silicon with V gamma 0.6 volt, RF 20 ohm. Assuming the diode to be on, so that the V0 is equal to 0.9 V1, 0.1 V2 and minus 0.54. That was the printing mistake. It is a 180 ohm. Okay. Then how we can solve it? What is written here? That the diode is shown in the circuit silicon, so that assuming the diode to be on. On means what? V1 is greater than V2. If the V1 is greater than V2, then the diode will be on. Now, in this case, if the diode is on, it is a practical diode. If it is forward biased, then it is replaced by V gamma and its internal resistance, that is called RF. That is the cut-in voltage. So what about the characteristics of the diode? This type of characteristics of the diode. Piecewise linear model, that is the characteristics of the diode. try to, now this is the characteristics. This is the characteristics of the diode. This is the V gamma, and this is 1 by RF, slope of this line. This is the current, and that is the VD, drop across the diode. That is replaced by, when it is forward bias, it is replaced by V gamma and RF. Okay. Now, practical diode. This is a practical diode. Then we can prove it by simply, they will ask what is the value of A, B, C. Then remember, first of all, replace this. That is the diode. Always remember, this is plus, this is minus. That's why that is the diode is replaced. V2. This is V1. And this is 20 ohm because this is the RF. And this is 0.6 volt V gamma. 0.6 volt, it is given in the question. RF is given as 20 ohm, and that is the 180 ohm. 180 ohm, and now we have to find the V0. Okay, that is the, now it is a question of what network. Apply the KCL. V0 minus V1 minus of minus 0.6 volt, because it is a polarity. So V0 minus V1 minus of minus 0.6 volt divided by 20. Apply the KCL, plus V0 minus V2 upon 180 is equal to 0. Now you can take 180 as a LCM. 20, that is what, 9. It will become 9 V0 minus 9 V1 plus 9 into 0.6, that is what, 5.4 plus V0 minus V2 is equal to 0 divided by 180. Now the 180 will become 0. 9 plus, this will become 10 V0 is equal to 9 V1 plus V2 minus 5.4. You can check. Now what is the V0? 0.9 V1 plus 0.1 V2 minus 0.54. It is proved. You can find the value of A, B and C. That is, what is the value of A? 0.9. What is the value of B? 0.1. What is the value of C? 0.54. There will be the 4 options. Out of 4 options, you have to choose one correct answer. MCQ. There is a negative marking. Okay, remember that. Yes, you can prove this. Simple means simply replace the diode by its model. That is called mathematical model, linear model, V gamma and RF. And then apply the concept of KCL, simple network. And then you will get the answer. Okay then. Then next one, next question. Okay. Assuming that the beta of the transistor is extremely large and VB is equal to 0.7 volt, IC and VC in the circuit shown in the figure. ये तो बड़ा easy है. This is a very easy question. So here in BARC we can expect this type of questions. Quickly give me the answer. Quickly. This is the 2.2 kilo ohm. If it is not visible, remember this is the 2.2 kilo ohm. This is the 300 ohm, 4 kilo ohm, 1 kilo ohm resistor. You have to find the VCE and you have to find the IC. This is the 5 volt battery, it is given. 5 volt battery it is given. Beta of the transistor is extremely large, means beta is very large. Then we can neglect the base current. Then apply the Thevenin's voltage division rule. So according to voltage division rule, what is the voltage at this point? 1 divided by 4 plus 1 into 5, that will become 1 volt. No need to find the RTH because beta is very large. No need to find the RTH. Already we have find the VTH. Always convert the resistor into kilo ohm. This is the 2.2 kilo ohm. This is the 5 volt battery and this will become 1 volt. This is the VTH. No need to find the RTH. This is the IB. And it is a silicon transistor. It is given. That's why the value of VB is 0.7 volt. This is written. VB is 0.7 volt. Okay. Then, what is the value of IE or IC? IE or IC is given by 1 minus 0.7 upon RE. What is the RE? 0.3. it will become 1 milliampere. 1 milliampere. Now what is the value of VCE? Always read the question carefully. They will ask VCE or VCE, right? Be careful about that. This time it is VCE is asked. Write down the KCL from this point to KVL from this point to this point. This is also IC because IB is 0. You can write 5 is equal to 2.2 times of IC plus VCE plus 0.3 times of IC. And IC is 1 milliampere, and that's why the VCE will become 5 minus 2.5 into 1 because IC is 1, 2.5 volt. 2.5 volt. So what is the answer given here? C. Yes, that is the right answer. That is the right answer. Yes. No, Karan, because they will not provide you the question paper. So memory based question paper for BARC exam. Similar type of questions in HPCL or similar type of question in BARC. What? It is a memory based question. Okay. Memory based question from BARC. Papers are not available. No, no problem. But ask your friends, ask your seniors. Already we have experienced that this type of questions they will ask. Okay. No problem. Already we have given the GATE exam. Recently we have given the GATE exam. So we have idea. It is a quick revision. Okay. Then this is the C option. So that get the idea about the potentiometer, and every time read question carefully because very limited time we have to solve more number of questions. There may be the chance of what silly mistake. They may ask what is the value of VC only. In place of VC, they will ask VC. Then answer will be different. VC means what is the voltage at this node. Then it will become what? 5 minus 2.2 times of IC. 5 minus 2.2 because IC is 1 milliampere and it will become 2.8 volt. That is the difference. Okay, that is the difference between VCE and what? VC. Okay. Next one. At the end, rapid fire round. Okay, we have to solve number of questions. So ready for that. First of all, solve the diagram based question, then rapid fire round. For the circuit shown, VPS is 5 volt. Where is the VPS? This is called DC voltage. Between these two terminals, this is the DC voltage is 5 volt it is given. And here the AC signal is also applied VI. Okay. Now, V gamma is 0.6 volt. That is the cut-in voltage of the diode is given. RF is not given. The input is 0.1 sin omega t. Determine the magnitude of output voltage V0. Always read the symbol here. That is a small symbol. Small means AC signal. You have to find the AC output. Second, all answers are given in millivolt. Very, very small voltage. Means again it is a small signal. What is the small signal output voltage? Tell me. What is the small signal output voltage? Then in that question, first of all, you have to find a dynamic resistance R. That is given by eta Vt by I. Diode current. Eta. If nothing is given, whether it is a silicon or germanium, nothing is given. The by default we are taking ideality factor 1. And Vt we are taking what? 26 millivolt. At 300 degree Kelvin. That is the 26 millivolt. Upon ID, you have to calculate the current diode. So you can check this value and find the value of the dynamic resistance. 26 millivolt is the value of Vt at what? 300 degree Kelvin. Vt is equal to Kt by Q. That is T by 11,600. New students, remember that K is the Boltzmann constant, Q is the charge, T by 11,600. Vt is equal to 0.026 volt at 300 degree Kelvin. And this is called dynamic resistance of the diode or incremental resistance of the diode. Then first of all, find the value of I. Then remember, okay, find the I means first make the DC 0, AC 0, DC is the 5 volt, diode is forward bias. What is the drop across the diode? Under DC condition 0.6. What is the value of the R? It is given 5 kilo ohm. Now you can find the current through the diode. ID is given by 5 minus 0.6 divided by 5, that is nothing but 4.3 divided by 5. 5 minus 0.6, that is 4.4 divided by 5. Okay. ID. Once you will get the ID, then find the dynamic resistance. Dynamic resistance. Okay. Eta. Vt by eta is 1, Vt by ID. That is 0. Or this is in milliampere. So you can directly write in 26 millivolt divided by 4.4 divided by 5. It is also in milliampere. So milli cancel. You will get the answer in ohm. You will get the answer in ohm. So everyone, what is the answer for this? You can find the dynamic resistance. Now once you will get the dynamic resistance, then under AC condition, this is replaced by small r and that is the capital R. Now this is the value, only AC signal. So what is the V naught? According to voltage divide rule, Vi into R upon small r plus capital R. So what is the asked here? Magnitude means amplitude. So what is the highest amplitude in AC signal? 0.1. You can directly write 0.1 into 5 kilo ohm. Remember 5 kilo ohm means 5000 upon small r. Put the value from this small r and then capital R. And you will get the magnitude. Yes. Right? So virtual calculator is available. Venkatraman, we have taken one general session for that. Okay guys. Now I think it is around 99.4 millivolt. You can check this answer. You can check this answer. Okay. So that is a very simple. Find the dynamic resistance, apply the potential divider rule and simply find the answer. So that is the answer for this question. Right guys. How? Okay. Now next one, next question. Okay, tell me what is the answer? What is the answer for this question? ये तो easy है यार, सब बनाइए ना आप लोग rough. Please use your rough, copy, pen, calculator, virtual calculator. Try to solve this question. Find absolute value of the peak current through the load resistor. Where is the load resistor? This is the load resistor RL, 2 kilo ohm. This is the 2 kilo ohm. This is the 2 kilo ohm. This is the RL. And this is given as 10 volt, 10 sin omega TVI. Find the absolute value of the peak current through the load resistor. Assume V gamma 0.7 volt for the diode. These are the practical diodes, 0.7 volt. My dear Ravi Teja, if suppose I am putting the cut-in voltage in case of what? AC, then what about the diode? Diode will be off. Okay, try to understand. Everyone take a screenshot and try to solve this question. Try to solve this question. What is the diode and what is the value? Remember in a previous question, always remember when we are connecting, this is the diode. We are connecting the two signal. One is called AC signal, that is a very small signal, and one is called DC signal. And because of this DC signal, that is diode is on. Means what is the diode? Actually we have the two signal. Now this is the DC and AC is superimposed on it. AC is superimposed on it. Now this is what is the DC signal? 5 and AC is 0.1 sin omega t. So highest value is become 5.1 and lowest value become 4.9. 5.1 and 4.9 both are greater than what? Cut-in voltage. Both are greater than cut-in voltage, and that's why the diode is in conduction. Are you getting my point, Ravi Teja? Diode is in conduction. Now, what is this? The AC is what? Very simple variation in the DC. And when go through this characteristics, actually the characteristics of the diode is what? Non-linear. The characteristics of the diode is non-linear. This is the characteristics. At this point, this is the cut-in voltage 0.6 volt. It is given in the question 0.6 volt. So I am taking the 0.6 volt. Now this is the 0.6 volt. It is given. Okay, no problem. Now at this point there is a variation. What is the variation? Only 5.1 and 4.9. So this variation is very small, and that's why it will maintain the linearity here. And what is the slope of this portion 1 by R? And this R is called dynamic resistance. R is called dynamic resistance. And that's why for this variation, the diode is replaced by that dynamic resistance. Now I think that is clear, and this is called small signal analysis of the diode. So during a small signal, it will maintain a constant slope, and the resistance for this portion is what? R. And that is the value of I. And we have already found the value of I. And that's why during AC analysis, we are not considering the cut-in voltage. We are simply giving what? Small r. Small r. Okay. So this is a small signal analysis. And actually the diode is non-linear device. But when the signal is very small, we are considering it what? Linear device. And that is called linear model. That is called what? Linear model. Linear model. Linear small signal model of the diode. Okay. Now, what is the answer? What is the answer? Tell me. Okay. Now, for 10 volt, what is the peak current? It is asked for 10 volt when the VI is 10 volt. Peak current means maximum value. Diode D1, diode D2. For 10 volt, because it is a positive, this diode is off. This diode is on. This diode is off, this diode is on, and this is the minus 10 volt. Okay, no need to check. Only you have this diode is off, it will act as open circuit. And then simply this diode is on, it is replaced by 0.7 volt because cut-in voltage is 0.7 volt. Two kilo ohm, 2 kilo ohm, 2 kilo ohm. That is given. And what is the voltage here? 10 volt. That is the maximum voltage is 10 volt. Okay. Then find the value of I. And finally, according to voltage division rule, you have to find I1. That is a very simple calculation. Right? Okay. Now, wow, क्या पूछ रहे हो भाई? Nandesh Krishna, you are giving the 9.3 divided by 4. That is the right answer. Please check. Now, this is the circuit, everyone. This is clear. This diode is off. That is clear. Now, first of all, you have to find the I. Then you have to apply what? Potential divider rule. So, 2 and 2. What is the 2 and 2? 4. 4 parallel with the 2. So, what is the R equivalent? Everyone tell me. 4 parallel with the 2. That is nothing but 8 by 6. 8 by 6 is nothing but 4 by 3. Okay. Now, this circuit is replaced by one resistor, 4 by 3, and that is the 0.7, and this is what? 10. Now everyone tell me what will be the I? Then I will become 10 minus 0.7 divided by what? 4 by 3. That will become 9.3 into 3 divided by 4 milliampere. This is the current, the value of I. Value of I. Now you have to apply what? Current division rule. So what is the current division rule? According to current division rule, now we are going to apply the current division rule here. So already have 9.3 divided by that. We have the value of I, my dear. This is the value of I only. Now what is the I1? I1 is given by I divided by 4 plus 2 into what? 2. So this is the value 9.3 into 3 divided by 4 into 2 divided by 6. So this is the 3, 2, 2, 2 cancel, 9.3 divided by 4. Now you can use your calculator. So 2 point something. Which answer is 2 point something? 2.235. Is there any use of calculator? Is there any use of calculator? Tell me. What is asked here? Peak current, that is asked here, guys. Okay. Peak current means what? Now, in the second case, if this diode is on, what will be the situation? I think that the situation is same. Situation is same. Yes or no? Special classes conducted. Yes, Nandesh Krishna. You are asking that in both the cases. Then in a second case, try to understand. If this diode is on, When it is negative, then this diode is replaced by what? 0.7 volt. Try to understand. This is R. This is the value. 2 kilo ohm, 2 kilo ohm, 2 kilo ohm. And now in this case, that is the value. 10 volt. Change the polarity. Now find the RR. That is the, we are getting the same value. What is the value of I? Again 2, that is the 4 by 3. 0.7, you will get the same. Now this I is divided into two parts. This is the I2 and this is the I1. And this is the RL. The same current you have to find I1. In both the cases we are getting the same answer because the magnitude is asked here. Acha Nandesh, you are saying, not asking. So theek hai na? You asked, you are saying, and some students are confused how to find the value. Okay, no problem. Okay, no problem. Okay then, okay, no issue. So analog, you are enjoying the analog. So in a class here we are solving very in class from bottom to what top level questions. Okay, this time, and everyone please solve the question from what instrumentation branch. Right, I will provide you the solution that instrumentation branch, very good question in this year GATE, right, from analog. One or two questions in operational amplifier, right, very conceptual question in instrumentation branch, everyone. That is my suggestion. Okay, the voltage gain. So quickly here in an exam, they will give you the very easy question. Within seconds you have to solve. What is the answer for this question? What is the answer for this question? Very simple. That is the small signal model for the MOSFET or JFET, we can say. Voltage gain AV of the amplifier circuit below, if GM is 0.04 Siemens and R0 is 100 kilo ohm. Right, now RS is not given, source is connected to ground, this R0 and RL in parallel, and this current will become minus GM V pi, and this is the V pi, this is connected to ground. So V pi is nothing but equal to what? Vs. V pi is equal to what? Vs. So directly V0 by Vs is equal to minus GM V pi R0 parallel with RL upon Vs is nothing but V pi. Vs is nothing but V pi. V pi cancel, and answer is minus GM R0 parallel with RL. Always remember, it is given in Siemens. You can convert it into millisiemens, or you have to convert this resistor in ohm. 0.04 Siemens R0. What is the R0? 100 parallel with 10. Kilo ohm is converted into ohm, so that you can set the unit. Now it is 9 point something, 0.04 into 9 point something. So multiply it into 10 raised to power 3. Multiply this value and you will get the answer for this question. Okay, what is the answer? What is the answer for this one? Something, this 363.6. Yes, this is the answer. Minus, because there is a 180-degree phase shift. 180-degree phase shift for this. That is a very simple one, within 20 or 30 seconds. Within 20 or 30 seconds. Now, NPN transistor made of silicon has a DC. Are new students, are you able to solve that? Easy one. Okay. So quickly we have to solve, because the number of questions will be more as compared to GATE exam. Then NPN transistor made of silicon has a DC based bias voltage 15 volt and input base resistor 150 kilo ohm. Then the value of the base current into the transistor, or it is written silicon, NPN transistor made of silicon has a DC base bias voltage of 15 and input base resistor 150. Then the value of the base current. Here we are reading, then we will draw the diagram. Directly you have to solve. Directly you have to solve this question. Okay. But number of students will draw the diagram that this is the RB, this is the DC biasing voltage, 15 volt it is given, 150 it is given, and now the VB is for silicon, it is the 0.7. No need to draw the diagram. Directly you have to write IB is equal to VBB minus VBE upon RB. No need to write this. Directly write 15 minus 0.7, 15 volt is the supply upon what? 150. and that is in milliampere. Convert it into what? Microampere, because answer is given in what? Microampere. Answer is given in microampere, means multiply it with what? 1000. 14.3 divided by 150 into 1000. 14.3 divided by 150 into 1000. Okay. Which answer? Yes. C. So please check the answer. No need to find. Simply the data is same. 0.953, 9.53, 95.3, 0.953. So use your value. This is around 0.1. That is multiplied with the 1000. Right. It will become nearly equal to 100. Which one is nearly equal to 100? 95.3 is nearly equal to what? 100. Okay. Virtual calculator is allowed, but we have limited time. Directly you can say. Okay. Next one. No need to draw the diagram. No need to write this equation. Directly write it and get the answer. Okay then. Now, quick, rapid round. Within 10 seconds, try to give me the answer. For a 50 Hz AC input, the ripple frequency in the output that a full wave rectifier produces is equal to. Everyone give me the answer in the comments box. Everyone, plus give me the answer in the comments box. For a 50 Hz AC input, the ripple frequency in the output that a full wave rectifier, whether it is a bridge type or what? Center tapped transformer type, what will be the ripple frequency at the output? You are giving yes, double. Ripple frequency is 2 times of the supply frequency, 100 Hz. In case of half wave rectifier, the ripple frequency equal to 50 Hz. These are the single phase rectifier. In case of 3-phase rectifier, what is the ripple frequency, everyone? That may be the question. FR is equal to 3 times of F for half-wave rectifier, or FR is equal to 6F for full-wave rectifier. For 3-phase rectifier, remember. In 3-phase, that will become where F is the supply frequency is the 50 Hz. Okay, supply frequency is the 50 Hz. This is for single-phase rectifier. Okay, so this is a quick revision. Now next one, next. Okay, good one. Ravi Teja, please check your calculation. The transformer utilization factor of a full wave bridge rectifier is full wave bridge rectifier. Everyone, please read the question carefully and give me the answer. Transformer utilization factor, that is also known as TUF. What is the value for half wave rectifier? What is the value for center tapped transformer type? And what is the value for bridge rectifier? Okay. Here we are connecting the diodes. Here we are connecting the RL. Here we are connecting the transformer. Okay. Which answer is correct? Quickly, quick round. So Himanshu, Ravi Teja, Karan, Ravi Shankar, Randesh. Yes, you are giving the answer A. That is the 0.812. Highest utilization factor for bridge rectifier. For half wave rectifier, it is 0.286. For center tapped transformer type, 0.693. And for bridge rectifier, this is the highest, 0.812. It should be as large as possible. As large as possible. Yes, your answer is correct. So now next question, rapid round. If the emitter bypass capacitor in a common emitter amplifier is removed, then what will happen? Quickly try to understand. Emitter bypass capacitor in a common emitter amplifier is removed, then, so this is answer is 0.812. Yes, one student has given the quick answer. Vanilla. Okay, Ravi Teja, everyone. Emitter bypass capacitor in a common emitter amplifier. This is the common emitter amplifier. Remember that diagram. This is the capacitor, bypass capacitor. When this bypass capacitor is removed, then RE will be in action, and because of RE, there will be negative feedback. And because of that negative feedback, what about the voltage gain? Reduces. And it is nearly equal to minus RC by RE. It will become minus RC by RE once C is removed. Highly stable. And input resistance will increase. Input resistance will increase. That is the value of the input resistance. Yes. So which answer is correct? Voltage gain will decrease. Input resistance will decrease, wrong. Voltage gain will increase, wrong. Voltage gain will remain unaffected, wrong. C is the correct one. Common emitter amplifier is removed. No. Input resistance increases, my dear. Stability increases because of the negative feedback. That is the input resistance because of RE. When we are connecting the capacitor, input resistance will decrease, voltage gain will increase. Now the stability will reduce. Yes, Nandesh, your answer is correct. तो यार ये देखो ऐसे क्वेश्चन आएंगे, right? Don't need to verify the again and again. Otherwise, you are going to waste your time. In BARC, you have to maintain what? Speed plus what? Accuracy. Speed plus accuracy. You have to maintain. Okay. Now tell me. An emitter follower amplifier has. Quickly give me the answer. It is a rapid fire round. An emitter follower amplifier has current gain that is always less than 1, voltage gain that is always less than 1, very small input impedance, very large output impedance. What is the another name of emitter follower? What is the another name of emitter follower? Common emitter configuration, common collector configuration, or common base configuration? Emitter follower. Okay. PDF I will upload the PDF. I will give just at the end I will give you the password, then you can download. Okay. Ravi Shankar B. Voltage gain is always less than 1. That is the right answer. My dear, for emitter follower, this is nothing but common collector. This is the common collector configuration. For common collector, voltage gain is nearly equal to 1, but actually practically it is less than 1. Input resistance is very high. Output resistance is very low. Current gain is high, 1 plus beta. Current gain is high, 1 plus beta. This is wrong, this is wrong, this is wrong, and B is the correct answer. B is the correct answer. This is a common collector configuration. Okay. Now, tell me, in a class A power amplifier, the collector dissipation is maximum when? Collector dissipation, because in a gate exam they are not asking the question from power amplifier, but in BARC they may ask question from the power amplifier. Quickly give me the answer. Class A, class B, class C. In a class A power amplifier, the collector dissipation is maximum when? Signal swing is maximum. Signal swing is 1 divided by 1.414 of its maximum. None of the above, or no signal is present. Yes, please. In class A power amplifier, where is the Q point in a class A power amplifier? Exactly at the middle of the active region. This is the class A. This is the IC. This is the VCE. This point is VCC, and what is the maximum current? VCC by RC. This is called DC load line, and this is the Q point for class A amplifier. When the signal is absent, there is a very large voltage at this point, and there is a very large current at this point. And that's why the power dissipation across the transistor is very, very large. This is the VCC by 2 into VCC by 2 RC. VCC by 2 RC means transistor will consume maximum power when the signal is absent. When the signal is absent. And that phenomena is known as what? Power drain. That phenomena is known as power drain. It will consume more power when the signal is absent, and the transistor will consume less power when the signal is present, because the DC power will convert it into what? AC power or useful power. The collector dissipation is maximum. Okay, so that is the B. And always remember, in this case, this is the power dissipation. The Q point is in the middle, VCE, and that is the IC, and this is the VCC. So what is the power dissipation across the transistor? VCE into IC, maximum. To get the idea about what class A amplifier, class B amplifier, class C, class AB, right, quickly. Okay. Then, tell me, in the adjoining current, अब इसको तो बता दो fast, give me the answer. In the adjoining current mirror circuit, this is the current mirror circuit, Q1 and Q2 are identical. Base currents are not neglected. We are not neglecting the base current. Beta is identical. Beta 1 and beta 2 is equal to beta. Then which of the following is true? Then which of the following is true? Okay. It is a question on what? Current mirror circuit. If you have the idea about the formula within 10 seconds. Within 10 seconds. Right, tell me. I1, I2, Q2, Q1. Okay. This is the question on current mirror circuit. Beta is not given, beta is large. It is not also not given base current. We are not neglecting. If we are assuming that the beta is small, then which answer is correct? Okay. So this is, my dear friend, it is a current mirror circuit. This is called reference current. And this is called what? Output current. And then always remember, there will be the identical, and that's why this voltage and this voltage are equal. VB, VB1 and VB2 are equal. Since the transistors are identical, that's why the base currents are also equal. And that's why we are having the 2 IB here. Here IB, here IB. And this is the nothing but IC2. And this I1 is divided into IC1 and IB1. And that is the IC1 and 2 IB. So from this, you can say I1 is equal to IC1 plus what? 2 IB. Since the transistors are identical, IC2 is equal to IC1 is equal to beta times of what? IB. We can write here, so what is the I1? IC1 we can write beta times of IB plus 2 IB. So what is the value of the IB? IB will become I1 upon 2 plus beta. And what is the value of the IC2 is equal to I0 is equal to beta times of IB, and that's why it will become beta times of I1 upon, right, beta plus 2. And that is the answer, beta plus 2. Beta upon beta plus 2 into I1, that is the C. C is the answer for this question, right? अरे विडलार और विल्सन नंदेस वो तो देखो एक्चुअली वैसा क्वेश्चन यहाँ पूछेगा या नहीं पूछेगा, आई हैव नो आइडिया, बट गेट द आइडिया अबाउट दैट. अदरवाइज इन नेक्स्ट सेशन आई विल गिव द आंसर. ओके, लिटिल बिट कंफ्यूज अबाउट द नेम. ओके, नो प्रॉब्लम, राइट. Sometimes they will connect what extra register here, and that's why the drop will change. Now we have various type of what? Current mirror circuit. Various type of current mirror circuit here. So this is a very simple current mirror basic circuit. So beta upon beta plus 2 into what? I1. This is the standard answer. Now if the beta is very very large, in this case if the beta is very very large, then we can neglect what? 2, beta cancel, and it will become nearly equal to what? I1. And that's why it is called current mirror circuit. What are the conditions? Beta should be large. No, the answer is C. What is the answer for this one? Fast, quick. Oscillator requires no feedback, negative feedback, positive feedback, either positive or negative feedback. Quickly. अब देखना silly mistakes. So oscillator means the amplifier with the positive feedback. Finished. There will be output without any input for oscillator. A upon 1 plus A beta, and that should be equal to what? Infinite. It is possible with A beta is equal to what? -1. Ideal condition. This is a positive. It is possible with positive feedback only. If you want again infinite. Then match the given feedback circuit with its proper nomenclature. Tell me. We have the 4 types of feedback. Voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback. What is this? What is this? The diagram. Please watch the diagram carefully. Watch the diagram carefully. Here we are having the series connection. Yes. Here we are having the series connection. Yes. There is no node. Both the sides series. It is a series comparison. Sorry, it is a series sampling, series mixing. Series sampling means current sampling. Current. At the output, we are sampling the current. At the input, we are mixing the voltage and mixing the voltage in series. So this is the case of what? Current series feedback. This is the case of current series feedback. Okay. Am I correct? What is your answer? At the output we are sampling the current, at the input we are mixing the voltage, and that's why it is a current series feedback. Because of this series connection, output resistance will increase. Because of this series connection, input resistance will also increase. Give me any one example for which we can say there is a current series feedback. Any one standard example, everyone. Everyone give me the answer. Current series feedback. Any one example. Already we have solved one question on that. Common emitter with unbypassed RE. We have the current series feedback. We have the current series feedback. Common source with RE. RS. This is the common emitter with RE. This is the common source with the RS. In both the cases, the feedback mechanism is what? Current series feedback. Input resistance and output resistance both increases. Both increases with RE. अच्छा नंदेश कंफ्यूजन होता है तो चलिए एक आध सेशन फटाफट लेते हैं इसके बीच में और अबाउट द फीडबैक, हाउ टू जस्ट द फीडबैक इन द सर्किट. ओके, so this is the case. It is again a current series. It is again a case of what? Current series feedback. In both the cases, input and output resistance increases, or we can apply what? Duals of Miller's theorem. In my class already have given duals of Miller's theorem. Dual of Miller's theorem. Again we can say input resistance increases. Okay. Now the oscillator with the best frequency, stability and accuracy is, यार ये तो बड़ा easy question, 5 seconds. The oscillator with the best frequency, stability and accuracy is Hartley oscillator, Colpit oscillator, RC phase shift oscillator, crystal controlled oscillator or crystal oscillator. Okay. Yes. Which one has the highest frequency, stability and accuracy? Fixed frequency, that is the drawback, but highest frequency is what? Highest stable frequency is D. And always remember d theta by d omega, that is called figure of merit. Figure of merit for oscillator. Everyone tell me what is the ideal value of the figure of merit? Ideal value of figure of merit for the oscillator. A 0, B infinite. Tell me what is the ideal value of the figure of merit for the oscillator, whether it is a crystal oscillator or Hartley or Colpit or RC phase shift oscillator. Tell me what is the value of the figure of merit, 0 or infinity? Vinay, you are giving 1. Oh, 1 means what? 0. I have given the two options only, 0 or infinite. It should be as maximum as possible. It should be as maximum as possible, and that is what? Infinite. That is what? Infinite. Right? And this is always remember this d theta by d omega is called figure of merit for oscillators, and this is the value is infinite and it should be as large as possible. And for crystal oscillator it is nearly equal to infinite. Nearly equal to what? Infinite. Remember that it is a new concept. Okay, it is a new concept. Go through the Millman Helmholtz at the end. That is given what is the figure of merit. Okay then, crystal control oscillator. Then, tell me, quickly give me the answer. Negative feedback is applied to an amplifier with the feedback voltage proportional to the output current. This feedback increases this feedback. Right. Okay, negative feedback. Again the question on the feedback is applied to an amplifier with the feedback voltage proportional to the output current. Proportional to the output current. This feedback increases the. Tell me which answer is correct. ये तो MSQ हो गया भाई. इट इज MSQ. चलो कोई बात नहीं. क्या लगता है रवि तेजा, ए और बी? Now negative feedback is applied to an amplifier with the feedback voltage proportional to the output current, means we are sampling the current. Sampling the current means series connection. Feedback voltage means this is the VF. Again series connection. Feedback voltage is proportional to the output current because we are sampling the current and we are mixing the voltage. And that's why series connection means what about the input impedance and output impedance? Both increases. Input impedance increases as well as output increases. यार तुम लोग तो बोला तो ये देखो output. This feedback increases the distortion. My dear, distortion will reduce. Gain of the amplifier will reduce. That is wrong. Input impedance increases, output impedance of the amplifier increases. A and B. A and B, Ravi Teja. Okay, A and B. Yes, Vinay Kumar, your answer is correct. Ravi Shankar Venkat Raman, check your answer. A and B. Both the, already I have solved now. Previously I have solved. That is, what is the example? Common source with RE register. Common emitter with the RE register. Common emitter, common source. Okay. These are the example. Already I have solved. Series connection, input and output impedance increases. Feedback voltage proportional to the output current. Okay. Next question. MSQ, that is MSQ is not in syllabus. That is just mistake in what question. Don't worry about that. Okay. Series means Himanshu. Always remember at the output when it is written that proportional to the output current. Always we are sampling the current in series. The current should remain same before sampling and after sampling. Right? If you want to give the same current, then the two component will be connected in what? Series. And that is the case. So output we have the series connection. At the input, it will affect the voltage. It will oppose the voltage. It will oppose the voltage. And we can subtract or add the voltage in what? Series. And that's why it is a series connection. In a series, at the input, we want to decrease the voltage. Vs minus Vf. And that's why the series connection. At the output, we want to maintain the same current through the RL and same current through the circuit, feedback circuit. And that's why these two are connected in series. Because in series, the current will remain same. And in this way, we can decide this is a series connection. Okay. Yes. Okay. Okay then. Now tell me. Read the keyword here. For a practical feedback circuit, to have the sustained oscillation, the most appropriate value of the loop gain is loop gain. BARC criteria. BARC criteria. Loop gain means in analog it is called what? Open loop gain. Remember, loop gain means open loop gain, my dear. In analog it is mentioned. It is not a closed loop gain. Always remember. This is called loop gain when the signal travels from the VI to output through the feedback network and back here, VF. And that is called loop gain from this point to this point. Yes. The most appropriate circuit have to sustain. Always remember the gain of, according to BARC criteria for practical feedback circuit to sustain the oscillation 1 plus A beta. Right, this is the gain. Always remember the A beta should be equal to what? -1. Practically. Ideally it should be -1. When it is -1, the gain will become infinite. The gain will become infinite. But practically it should be, the magnitude of mod of A beta should be slightly greater than 1. Slightly greater than 1. Then which answer is correct? Magnitude should be, no doubt, ideally it should be equal to, exactly equal to 1. Exactly equal to 1. Are you getting my point? A beta. Okay. BARC criteria means what? An amplifier can be converted into oscillator. An amplifier can be converted into oscillator. So what is the gain for the amplifier? This is the gain, A upon 1 plus A beta. When it will convert it into oscillator? When the gain is infinite. When the gain will be infinite? When the A beta should be equal to -1. When the A beta is exactly -1, the gain will become infinite. Okay. But practical, what is the practical consideration? The mod of A beta should be slightly greater than 1. Should be slightly greater than 1. No. They will, if it is nothing is mentioned, always remember. Ravi Teja, always remember, we are converting amplifier into what? Oscillator. We are converting amplifier into what? Oscillator. When we are saying the amplifier is converted into oscillator, means there will be the negative feedback. Then how the negative feedback is converted into the positive feedback? Then that is the BARC criteria, na? That is the BARC criteria. Go through the standard textbook like what Millman has. You will get the idea. This is the amplifier. How we can convert this amplifier into oscillator? It should satisfy the BARC criteria. Then that is the gain of the amplifier. So this A beta should be equal to -1. Then the gain will become infinite, and the magnitude of this mod of A beta should be slightly greater than 1. Then this is the value. Okay. I think now it is clear. Yes. Automatically this will convert into positive feedback. Automatically, once any amplifier will satisfy the BARC criteria, then effectively there will be the positive feedback. Effective, there will be the positive feedback. Okay. Next one. BJT Darlington pair has, what is the Darlington pair, everyone? Common collector followed by the common base, common emitter followed by the common base, common base followed by the common emitter, common collector followed by common collector. What is the Darlington pair? Quickly, now within 5 minutes. गायकवाड़ में भी दिया है ऑसिलेटर. यस यस, यू कैन रीड. गायकवाड़ में है, जैसे आपका मिलमन हेल्कियस में है. तो BARC क्राइटेरिया एक एम्पलीफायर कैसे सेटिस्फाई कर रहा है. एंड इन इंटरव्यू दे विल आस्क, हिमांशु कुमार, सी BJT Darlington pair has, what is this Darlington pair? Common collector followed by common base, common emitter followed by common base followed by common emitter, common collector followed by common collector. What is this? Darlington pair. Yeah, Ravi Shankar, common emitter followed by common base is what? Cascode amplifier. What is the cascode amplifier then? Direct coupled amplifier. Cascode amplifier is common emitter followed by common base. Darlington pair is what? Common collector followed by the common collector. Common collector followed by the common collector, D. Now, why we are connecting the common collector followed by the common collector? This is the common collector followed by the common collector. This is the V0, and here we are connecting Vs. Now, the input resistance at this point, it is very high, 1 plus HFE square into what RE. Input resistance is very high. Okay, that will become very high. High input resistance device, then current gain will also become very high, 1 plus HFE square. For one transistor, 1 plus HFE. For another 1 plus HFE, they are connected in cascade. That's why the total gain will become 1 plus HFE square. And the current gain is very high. Voltage gain is very low. For common collector, voltage gain is nearly equal to 1. Again, second one is common collector 1. 1 into 1 is nearly equal to 1. Then the voltage gain is 1. Voltage gain is nearly equal to 1 because it has one gain, 1 into 1, 1. But current gain is 1 plus HFE multiplied with 1 plus HFE, very high current gain. For example, if you are putting the HFE is equal to 199, let the beta is 199. What will be the gain will become? Everyone tell me. 199 plus 1, that is the square, 40,000. Are you getting my point? 40,000 is the gain, very high. And that is called what? Beta effective. Because the current gain is called beta effective or HFE effective. This is very large, and that's why this circuit is called super beta transistor. What is the another name of this circuit? Super beta transistor. Remember all these things. Remember, in analog, that is very important one. Okay. Super beta transistor. High input impedance and high beta. A is the answer. You are confused with what cascode and Darlington pair. Okay. Now next question. Quick round. Quickly give me the answer. Okay यार, एक बार शेयर कर लीजिए सबके साथ. अच्छा क्वेश्चन ऐसे ही आएंगे ना यार. I will provide you the other different types of question already in GATE we have solved, but this type of question, right? In BARC within 2 hours we have to solve what, around 100 question. Name transistor amplifier with 85% of efficiency is likely to be super beta. Transistor amplifier with 85% of the efficiency. This is the A. This is the B at cutoff. This is the AB, and below that it is C, and so on. Now, my dear friend, we have the maximum efficiency for what? Class C. It is the 25% for direct coupled and 50% for transformer coupled. Transformer coupled class A 50% maximum, or direct coupled 25. B 78.5% maximum. AB less than 78.5, greater than 50%. And the class C is nearly equal to 90, then we can say 85% of efficiency class C. Distortion. When we are moving from this point to this point, distortion increases, efficiency increases. Distortion increases, efficiency increases. D is the answer. So remember that class A, class AB, class B, and class C. Class A in the middle of the active region, class B at the cutoff, class C below the cutoff, and class AB between A and B, but near to cutoff. Now, next question. In a class AB amplifier, the current flows through the active device for, that is the conduction angle. Everyone give me the answer. What is the conduction angle? Just tell me. This is the class A, this is the class B, this is the class AB, and that is what? Class C. Okay. Less than half of the duration of the input cycle, half duration of the input cycle, more than half but less than the full cycle, full duration of the input cycle. Yes, Payas Kumari, Ravi Teja. Okay. For A, angle is what? 360, full cycle. Class B, 180 degree, half cycle. Class AB, between 360, more than half but less than full. Which answer is correct? C. More than half but less than the full duration. And for class C, less than half, 180 degree. This is between 180 and 360 for AB. That is the class AB. Okay. Okay. So what is the answer? This one. More than the half but less than the full cycle duration. Tell me. Consider a basic amplifier circuit having an input resistance Ri 10 kilo ohm and output resistance 1 kilo ohm. Now, last 5 minutes. Last 5 minutes, give me the answer for all the questions. Last 5 minutes. Okay. Consider the basic amplifier circuit having the input resistance 10 kilo ohm and output resistance 1 kilo ohm. The loop gain means A beta. 10 to the power 4, it is given. What are the maximum possible output resistance and minimum possible input resistance respectively? Right? We have the 4 types of feedback. Voltage series, voltage shunt, current series, current shunt. In which case, the output resistance will increase and input resistance will decrease. Everyone. In which case, the output resistance will increase and input resistance will decrease. Input resistance decrease means we are having the shunt connection at the input side. At the input side, we are having the shunt connection. Or output resistance increases means we are having the series connection. Here we are having the series connection. Here we are having the shunt connection. Series means we are sampling the I0. Shunt means we are mixing the current. Current upon current. Input current, output current. The basic amplifier is the current amplifier. Basic amplifier is the current amplifier. Right. Loop gain is given. My dear friend, but remember, directly you can solve. Input resistance decreases means Ri upon what? 1 plus. That is what? It will decrease beta. A. Or output resistance increases means what? R0 into 1 plus beta A. Finished. Multiply and divide by the desensitivity. So Ri upon 1 plus beta. What is the Ri? 10 kilo ohm. 10 kilo ohm divided by 1 plus beta. A beta is 10 to the power 4. Loop gain is given as 10 to the power 4. 1 is negligible. It will become 10 divided by, that is the 10 to the power minus 3 kilo ohm. Means it is 1 ohm. It is 1 ohm. And what is the output resistance? 1 kilo ohm multiplied with the 10 to the power 4. That is the 10 to the power 4 kilo ohm. 10 to the power 4 kilo ohm. So output resistance will become 10 to the power 4 and input resistance will become 1 ohm. Always read question carefully. What are the maximum possible output resistance and minimum possible input resistance? So remember the concept of feedback. Input shunt connection, output series connection. At the output we are sampling the current, at the input we are mixing the current, and that's why the basic amplifier is what? Current amplifier. Basic amplifier is the current amplifier. No doubt in this question the loop gain is given directly. You can put the value 1 plus beta A, and this is the value. Divide it, multiply it. Input resistance decreases, output resistance increases by factor 1 plus beta. Chinmay, any doubt? Ravi Shankar, Ashish Kumar, Payas Kumari, any doubt? Okay. Please revise all the feedback topology. Then, which of the following amplifier class suffers mainly from the problem of crossover distortion? Tell me. I am just mixing the question. One question from feedback, one question from power amplifier, one question from what? Diode, and simply give me the answer. Which of the following amplifier class suffers mainly from the problem of crossover distortion? COD. This is a non-linear distortion and it arises when conduction transfer from one transistor to other, and that is the problem of class B amplifier. Class B. And in class AB, that is the solution. In class AB there is no crossover distortion and this is the class B. But what is the class B? Efficiency is high and it is nearly equal to 60%. When we are entering into the class AB, COD is removed but efficiency also decreases. Remember that. Okay, next one. Which of the following best describe a class A amplifier? Best describe the class A amplifier. Okay, sir, आपके lecture, thank you. Okay, attempt हुआ नेटवर्क वगैरह के क्वेश्चंस? तो चलिए ये कॉन्फिडेंस आना चाहिए. मैं भोपाल में था, मैं जब पढ़ा रहा था तब एक स्टूडेंट ने आके मुझे बताया, मैंने क्लास बस ली, मतलब एनालॉग चालू बस हुआ था अराउंड, मतलब 30 डेज का एनालॉग था, अराउंड मैंने 20 डेज लिए होंगे एनालॉग. तो आफ्टर 20 डेज सेल का एग्जाम हुआ, राइट, SAIL, और वो स्टूडेंट देने गया, बोले सर लाइन से आपके नोट से क्वेश्चन थे इन व्हाट सेल डायरेक्टली. तो यार स्टूडेंट को कॉन्फिडेंस आया, जो क्लास में बैठे उनको कॉन्फिडेंस आया कि अच्छा ऐसा ही आता है क्या. तो क्वेश्चन देखो, जिसको भी लगता है कि पेपर गया अच्छा गया तो आप अपने कमेंट्स बॉक्स में बता सकते हैं. नोट्स फॉलो करो यार, हम अपने एक्सपीरियंस के साथ आपको सब कुछ बता रहे हैं. तो कमेंट्स में दीजिए आप कैसा पेपर जा रहा है और कॉन्फिडेंस रखिए, राइट. विद आवर फुल एक्सपीरियंस वी आर गिविंग ईच एंड एवरीथिंग. विच ऑफ द फॉलोइंग बेस्ट डिस्क्राइब लो डिस्टॉर्शन एंड लो एफिशिएंसी? तो लो एफिशिएंसी, लो डिस्टॉर्शन, लो एफिशिएंसी एंड व्हाट? लो डिस्टॉर्शन. Okay, C is the answer. Benila, you are giving the B. No. Efficiency is also low, distortion is also low. Class A amplifier. Always remember, efficiency low, distortion low. When we are increasing, when we are going downward, efficiency increases, distortion increases. More distortion. Right? But efficiency also increases. Okay. Low efficiency and low distortion. Okay. Now, next one. In which of the following amplifier classes the active devices operate for the whole input signal cycle? In which of the following amplifier classes the active devices operates for the whole input signal cycle? Very simple. Full complete cycle the amplifier will work. That is already I have solved. 360 degree. A. For the input, full complete input cycle, class A. Last one. In which class of the amplifier it is theoretically possible to achieve 100% efficiency, nearly 100% efficiency, right? In which class? Class D, class A, class AB, class C. ये तो एकदम already we have solved. Class A, what is the efficiency? Class AB, what is the efficiency? Class C, what is the efficiency? They are nearly equal to 100% efficiency. Tell me. 100% efficiency. right. और क्या we will provide you all the detailed current that इसी ब्रांच कौन कौन से AE JE एग्जाम के लिए एलिजिबल है, इसके ऊपर एक सेशन लेना पड़ेगा. That is the class D nearly. Class D. What that is, it is another class for digital amplifier. Right, we can achieve around 100% efficiency. Right, this is a different type of amplifier. So class D amplifier. Okay. Then, which of the following harmonic component has the main contribution in the total distortion? Why I am taking this? Because number of students are not having idea about the power amplifier. So quickly solve the question. Quickly. Right. Here ऐसे ही आते हैं. और already I have given you the numerical now. Already we have solved the numerical on the diagrams. Which of the following harmonic component has the main contribution in the total distortion in an amplifier? You have idea, then you can calculate. I will give you the formula how to calculate the efficiency. What are the formula for that? Okay, second harmonic component. Second harmonic component, that is called D2. Okay then. So this is about session, my dear friend. Now I am going to give you the one or two more assignments. Everyone try to solve this numerical or quickly give me the answer. Quickly give me the answer. ID this sir please explain means what? Ravi Shankar क्या हुआ? For the circuit shown below, the value of V0 by Vi. Always remember the current through this R is what? Negligible. Then you can apply the virtual short concept. Voltage at this point is 0, voltage at this point is 0, and this is no need to consider this R. It is an inverting operational amplifier. What is the gain? Minus RF by R1, that is nothing but minus 400 by 40, that is 10. Minus 10 is the gain. Minus 400 by 40, that is the minus 10 is the gain. Right, okay. Then second, गेट सिलेबस में नहीं आया आशीष, बट इन अदर कॉम्पिटिटिव एग्जाम्स वी कैन एक्सपेक्ट क्वेश्चन, अदरवाइज one or two question. Okay, that is the question from the operational amplifier, right? And then I want to give some one or two assignment. Everyone try to solve that question. Okay, everyone in comments box give me the answer for this one. First assignment for you, you can take a screenshot and now write the password. Okay, this is the password, very easy. Student ढूंढेंगे BARC 2023. Okay, BARC 2020, so all in small letter, and that is the P. Yes, it is just a comparator. We are giving the signal to the positive terminal, and that's why, and it is just a comparator. We are having what? Square wave. You have to check the frequency of that. You have to check the frequency of the output waveform. Okay, which one you are asking, Ravi Teja? Don't know how the previous question harmonic. Acha, harmonic wala, that is I will prove that second harmonic distortion is the highest one, because when frequency increases, amplitude decreases, and the most appreciable harmonic distortion is what? Second harmonic distortion. Okay, that is the B, right? Now last one, quickly give me the answer. Ripple factor for a half wave rectifier is, at the end, very easy question. Ripple factor. On my Telegram channel, I am just sharing the link with you. Everyone, please join that Telegram channel, Electronics by Sanjay Sir. Okay. This is my link, Telegram channel, Electronics by Sanjay Sir, and simply I will upload the PDF, and that already I have given the password. This is the 1.21. So, okay, everyone, first of all, try to understand. Already we have solved number of questions in for GATE exam, right? Now, this is the time to revise your short notes. Revise all the standard tables for rectifier. What is the formula for the ripple factor? What is the formula for the form factor, crest factor, RMS value, transformer utilization factor, about what power amplifier, feedback mechanism, standard circuit. No doubt we have to solve some numericals, but there will be the balance between what numericals and theoretical question. Okay, in a limited time we have to solve more number of questions as compared to what GATE exam. That's why there will be the change in the pattern. So first of all, theoretically, if we are getting this type of question, within 10 to 20 seconds we have to give the response. Then we will get the time to solve what numerical type of questions. Okay, and that's why revise all these things. Some students are confused with what cascode amplifier and what Darlington pair. So what is the cascode amplifier, Darlington pair, bootstrapping circuit, right? Emitter follower, source follower, voltage follower, non-inverting op-amp, inverting op-amp, bistable, monostable, unstable multivibrator. What are the properties? Please revise all these things. Okay. Right, peak inverse voltage. Yes, we can say what is the peak inverse voltage. So hope so you enjoy the session. You are on BYJU'S Exam Prep. Thank you for attending the session. Please like the session, share the link of this session and subscribe our channel. Thank you very much. Good luck for all exams and good night. Thank you.